Okay, hi guys. So in this lecture, we'll be starting off with a new chapter, which is solid state. So let's get started. Okay, so first of all, let's see the classification of solids. So solids can be classified broadly into two categories. First is crystalline, and second one is amorphous. Crystalline solids and amorphous solids. Okay. So crystalline solid have the constituent particles arranged in regular pattern. Constituent particles arranged in regular pattern, and in amorphous solid we have constituent particles randomly present. Next, we have in crystalline solids, they have definite geometric shape, and amorphous solids have no definite geometric shape. Okay, so or we can also write they have irregular shape. Next, they have long range order, and amorphous solid have short range order. And example of crystalline solids can be NaCl, ZnS, diamond, CSCl, etc. And example of amorphous solids can be glass, rubber, plastic, etc. Okay, next, when we cut crystalline solid with sharp edges, we have smooth surfaces which are generated. So when we cut crystalline solid with sharp edges or sharp edged tool, smooth surfaces are generated. And in case of amorphous solids, when we cut it with a sharp edged tool, uneven rough surfaces are generated. With sharp edged tool, uneven rough surfaces are generated. Okay, next we can write that crystalline solid have sharp, or in other words you can say definite melting point, have, but let's write it sharp only, have sharp melting point, whereas amorphous solids have diffused melting point. That means we have a range of temperature in which the amorphous solid can't melt. So amorphous solid have diffused melting point. or in other words we have range of temperatures. Next, crystalline solid have definite characteristics. Or delta H of fusion, whereas amorphous solids have no definite delta H of fusion. Okay, next, these are true solids and these are pseudo solid or supercooled liquid. These are pseudo solids or supercooled liquids. Crystalline solids are anisotropic. They are anisotropic, and amorphous solids are isotropic. Okay, so by the way, what is anisotropic and isotropic? So let us first define anisotropic. So anisotropic are the substances that have different physical properties along different directions. Okay, so substances that have different physical properties along different directions. Okay, and isotropic are the substances which have same physical properties even along different directions. Substances that have same physical properties even along different directions. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing more on solid state. So till then, good luck and goodbye.